Good morning, students. In last class, we completed the differences between distance and displacement, and we studied in detail about uniform motion. This was the last slide. I hope you remember this one. So let me revise what is uniform motion. So students, I quickly revise uniform motion. So the characteristics of uniform motion are: uniform motion is when equal displacements occur during any successive equal time intervals. Second one is uniform motion is always along a straight line. So these are the basic characteristics of uniform motion. Okay, now we are going to start with the next slide, and that is uniform motion. Student, this one is the graphical representation of uniform motion. You can see in this diagram, this one is the graph plotted for uniform motion of any object started with some position. Suppose this one is point A. Okay, started from point A. So you can see in this interval of time it travels this much distance, then these intervals are equal. Okay, so it travels this much displacement. Actually it travels this much displacement here. Similarly, you can see here this displacement. Okay, this one, or you can draw it along the direction. This one is the displacement, this one is the displacement, this one is the displacement. So you can see in equal intervals it covers equal displacement. So this motion is known as uniform motion, equal displacements in different time intervals. So an object's motion is uniform if and only if its position versus time graph is straight line. Okay, so these are other characteristics of uniform motion, and you can say the motion is uniform if graph between displacement time or position time same graph is shown in this diagram. If it is straight line, then motion is uniform. Now the average velocity is the slope of the position versus time graph. So if you find out the slope, you know slope is found by this triangle. In this triangle, if this angle is theta, this angle is theta, so you can get slope. So this slope theta is equal to delta x upon delta t. This one is delta t. Okay, this one is delta t, this one is delta x. So tan theta is equal to, if you need you are watching for the slope, it means tan theta. So tan theta is equal to this displacement upon this time interval. Okay, so it means tan theta is equal to delta x upon delta t. Okay, and you can see this one is the velocity. Because motion is in a particular direction, it means it has some fixed direction. So this one is the velocity, and this velocity is uniform because delta x is constant and delta t is also constant. If velocity is uniform or same, it means motion is uniform. Okay, so you can see the second point, the average velocity is the slope of the position versus time graph. Okay, so this one is slope delta x by delta t. This will be equal to the velocity. Now there's a unit of velocity is meter per second. This we know already. You can see the slope is equal to the average velocity. So slope is delta v upon delta x upon delta t, or it can be delta y upon delta t. If you take y along the direction, it depends on your choice, but in general this should be y. So you can take delta y by delta t, that is slope of position time graph. Okay, so there is one very important question, that is, if graph is given and you want to find out the value of uniform velocity, or velocity of the object. So you have to find out, or you should try to calculate the slope of that curve. By calculating the slope you will get the average velocity of uniform motion of object. Okay, so I hope you are getting my point, and I hope you understand how will you get velocity of any object from a graph or position time graph. Okay, so let's start the next one, that is speed and time. We are trying to differentiate between speed and velocity. Okay, so what is definition of speed, what is definition of velocity, I hope you know, but also I am trying to define once again this. So distance travel per unit time is known as speed. Okay, for speed we should not use the displacement, but if motion is a straight line, then distance and displacement are same, then in that case we can say distance and displacement are same. So distance travel per unit time is known as is known as speed. Okay, so speed means distance travel per unit time. If you take displacement here, that will be velocity. So for velocity, displacement will be divided by time interval, and for speed, distance will be divided by time interval. The SI unit for both are same, that are meter per second, because distance has unit meter, displacement also have unit meter, and time in both the cases have unit same, that is second. So the SI unit for speed as well as velocity are same, that is meter per second. Okay, so I hope you understand. Speed is scalar because distance is scalar, velocity is vector because displacement is vector. So speed, this is the basic difference between speed and velocity. When an object is traveling along a straight line, its velocity is equal to its speed. Very nice. This point is very interesting. So in some of the cases, speed and velocity can be same, and that is case when when motion is in straight line. Suppose an object is moving like this in uniform motion, it means its distance and displacement both are same. So speed and velocity in magnitude are same, but there will be no need to write direction if we write about the speed, but there will be need of the direction when you are talking about velocity. Okay, so this is the interesting result. Speed and velocity of any object can be same when the object is moving in straight line. Okay, so this point is very interesting, you should note this point. Okay, now we are going to understand the distance time graph. Okay, so since motion is in straight line, this is the motion in straight line, you can replace this distance by displacement also. So you can write here displacement also. It means from this curve you can calculate, after getting this angle theta, you will get velocity as well as speed both. Okay, you can see in the equal interval of times, you can see this interval is of 10 second or 10 minute or 10 hour if you represent, but time is represented here in seconds, and this distance is in meter. So you can see this interval of 10 second, this one is again interval of 10 second, this one is again interval of 10 second, because if you difference between 30 and 20 is 10 second, similarly difference between 20 and 10 is 10 second. So you can see this time interval, this time interval, and this time interval are equal. Okay, similarly you can see here the distance differences. You can see this one is 5 meter, then this one is again 5 meter, this one is again 5 meter and 5 meter. Okay, so it means in each 10 second object travel 5 meter. So this one is 5 meter and this one is 10 second. So what should be the velocity? So this angle tan theta is equal to perpendicular upon base. So this one is the perpendicular and this one is base in this triangle. Okay, so you can write v is equal to 5 upon 10, or this will be equal to 1 upon 2. So this will be the velocity or speed of this object for which this graph is plotted. Meter per second will be the unit. You can write here meter per second. Okay, so similarly you can calculate the values. If this is distance, then this will be the speed. If this is taken at displacement, this will be velocity. So you can take the things according to the choice. I hope you are getting my point. So this one is the distance time graph, and by taking or by getting value of this slope, you can calculate the velocity as well as speed of a moving object, but motion should be uniform, then only this graph will be straight line. Okay, now we are here at velocity time graph. So this graph is distance time. Let me make you clear, because don't get any confusion. This one is distance time graph, or it can be displacement time graph. The both nature of both graphs will be same. If distance is if this distance is replaced by displacement, then also the graph will be same. Okay, so this one is distance time graph, but next one is velocity time. It in this distance time, on y-axis we plotted distance or displacement, and on x-axis time. But in velocity time graph you can see on y-axis displacement is replaced by speed or velocity, and x-axis is same time. We can replace this speed here and time here, but for simplicity or for uniformity we are doing this, means we always plot time on x-axis and other quantities on y-axis. Okay, so let's understand velocity time graph. You can see velocity throughout the motion remains same. It means here velocity will be 0.5 meter per second, then here 0.5, 0.5, 0.5. It means at all the instant of time velocity will be 0.5 meter per second. It means you can see at 10 second velocity is 0.5, then between 10 to 20 at any point this will be the same. Similarly at 20 this will be same. Similarly at 25 this will be same, and for other time intervals. So you can see this line is straight and parallel to x-axis. This shows that the motion is uniform and speed or velocity of the object is constant throughout the motion. So I hope you understand difference between these two graphs. Student, these two graphs are very interesting, very important. You can see the slope of distance or displacement time graph gives the velocity or speed of the moving object. Point to be noted. Note it point. Note this point. Okay, the slope of distance time or displacement time graph gives velocity or speed of the object, whereas you can see if a motion is uniform, the velocity or speed of the object throughout the motion remains constant. It means the graph will be a straight line parallel to the time axis. Okay, so you can see this one is a graph for velocity time in uniform motion. Okay, so I hope you understand and you are getting my point. You can draw draw different graph for velocity, time and distance and displacement time for different moving object. Okay, and check yourself during motion, either your motion is uniform or non-uniform. Write examples of object which are in uniform motion or non-uniform motion. But I hope you understand the difference between these two graphs which are shown in this slide number 1 and slide number 2. Okay, so revise this topic. I hope you understand and enjoy this session. Thank you for watching. Thank you once again. In next session we will start from the non-uniform motion. Okay, so if you get time, read about non-uniform motion, which will help you to understand. Okay, thank you students.